Alright guys, so we're moving ahead to object-oriented programming, which we actually saw some when we did the structures. When we did the struct and we were able to store data in it. Well, a class, which is what objects are made from, is the same thing as a structure, but you add functions to it. And once you add those functions to it, they're called methods. Now, technically, in the C++ language, there's no difference between a struct and a class, except that all the members of a class are by default private rather than public. That's the only difference. But conceptually, what people usually do is if something's only got data, they use a struct, and if it's got data plus functions, it's class. So this starts talking about procedural programming, focuses on the process actions that occur in a program, whereas object-oriented programming is based on the data and the functions that operate on. Objects are instances of abstract data types that represent the data and its functions. So the limits of procedural programming. If the data structures change, many functions must also be changed. In functions, programs that are based on complex function hierarchies are difficult to understand and maintain, difficult to modify and extend, and easy to break. So let's go in and get Visual Studio going. I'm going to make a lecture X. How about a brand new lecture X, since the one that I did yesterday is of no importance now. Give me a break. I just did that. All right, so pretty sure everybody's familiar with the game of Pac-Man, right? Hopefully. We come over here and start Pac-Man just for giggles for a moment. All right, so in Pac-Man, you are the yellow pizza-shaped thing running around, eating the dots while the ghosts pursue you, right? And the more dots you eat, the faster the ghosts move. And once you get up and eat one of these power pellets, then the ghosts turn blue for a while. And, eating them gets you extra points. But the blue time runs out after a while, right? And so the ghosts then turn back to their normal and they start chasing you again, right? So, I know you have the idea. So one of the interesting things about Pac-Man was, or is, that the ghosts do not all just chase you the same way. Because if they did, they would just all zero in on you and catch you every time, right? If they all worked with perfect intelligence, they would just zero in on you and follow you, and then boom, you'd be dead. So instead, they all kind of have their own different way of deciding where to move. And so, for example, the red one chooses as its target position a spot a few squares behind you. And the reason it does that is because it's trying to tail you, and then once it gets within those few squares, then it's instead targets you directly rather than to spot a few things behind you. Whereas the pink one kind of tries to cut you off, so it targets a space, a couple of inches ahead of you. And then once it gets, within a certain distance, it zeroes in on you instead. And the blue one does an even more strange algorithm where the distance between you and the red one and then that much farther is its target. So if the red ghost was here and you were here, then the blue ghost's target is right here. And so it's kind of just hanging around doing its own thing, going towards the wrong target until he gets closer and closer to you, in which case his target becomes closer and closer to you. So he kind of works in tandem with the red one. So whatever. And the orange one just wanders around doing its own thing, never really doing any good whatsoever. So if we were going to write a program to do these ghosts, and we wanted to, here's what we could do, right? We could make a I don't know, some ints called X position for ghost 1, the Y position for ghost 1, and maybe we do the same thing for the ghost 2 and ghost 3 and ghost 4. And what else do we need to know about the ghosts other than their position? We need to know, I don't know, what direction they're going, right? Which we might represent as a direction, as an int, north, south, east, west. So the direction for ghost 1, comma, direction for ghost 2, comma, the direction for ghost 3, comma, and the direction for ghost 4. And we need to know their speed, right? So we might need 4 integer variables for their speed. Now this is getting kind of unwieldy already. So this is not going to be our final answer. I should have just already had this typed up because it's kind of tedious doing that. All right. And so then if we were going to draw the board, now we're not going to really, right? This is just for demonstration. We could write a function called draw board, and it needs to take all this information. Wow, that's a lot of information. I'm so sorry, excuse me. All right, we need to take the position of ghost 1, X position right here. This is just insane. I would have to copy all this and paste it in here. And put int in front of all the keywords. Remove all the semicolons. Remove all, yeah, keep going. Getting there. Int there. Int there. Man, that's a lot of function staff to, that's a lot of argument staff to pass to a function, right? That's a whole heck of a bunch. Alrighty. There. And now we finally got it, right? Except I apparently still got some syntax errors. I don't know what I've done wrong here. Oh, I've got duplicate names. Wonder what I was doing there. Oh, that was supposed to be X position and Y position, right? Because he's got an X and a Y coordinate on the screen. So just to get it to the point where it looks like it can compile, I'm going to correct those, and I'm probably going to wind up deleting this stuff. So, I'm having to pass around all this information. And yeah, maybe there are ways I could try to shorten this, like maybe I can make an array called X position, and it's going to be 4 long, and then the position stored in element 0 is supposed to be for the first ghost, and the X position of the second ghost is stored in 1, and we make another array for Y positions, and we make another one for speed, and another one for the direction. Okay, so, we've got data, and it's not organized in any real sense whatsoever. This was a failed effort. This is more procedural programming. You define your data, and you keep that data around, and you pass it around to functions, and then those functions return. We're going to do a little bit more object-oriented approach, where we need to think, what data does a ghost need to have? Oh, and while we're here, why don't we go ahead and include string and do using namespace std, right? Okay, so what does a ghost have? Same kind of things we were talking about. We need to know the ghost's X position and its Y position. We need to know the ghost's speed. We need to know its direction. It might be nice to know its name. Each ghost has a name, but even if we ignore that, we need to know the ghost's color, and we might need something to represent its algorithm, right? Whether it's using the one that trails you closely or the one that tries to head you off, or the sneak attack one or the stupid one, right? So we might need a variable for the algorithm, which algorithm we're going to use. All right. So let's define a class called Ghost. Let's skip algorithm. We don't need to worry about that. But X position and Y position could be ints. So could the speed, right? The direction, well, yeah, you could represent it as an int, but it'd be better to define a variable type that was limited only to 4 values, right? Because he can only go north, south, east, or west. So we're going to create what's known as an enumeration. And here's what it looks like. We're going to make a type called color. And we only support 4 colors. Red, blue, pink, and orange. And heck, since Pac-Man's yellow, let's add a 5th color. Alrighty. And how about directions? Directions and colors, the same thing. We just have limited supplies of those. We only have a specific set of things that we want to be able to do. We want them to be able to go up, right, down, left, going clockwise. North, east, south, and west. All right, so let's define our ghost. Class Ghost. Well, a ghost has an int, an X position, and a Y position, right? It also has a color. So color looks funny. Now we're not going to give it a default color because we don't know. We don't want all ghosts to have the same color. But if we did want to give it a default color, we would just do color : blue. Whoops. Right, like that. You could actually even leave that part off, but some variants of the C language want you to put that color : there. It kind of makes it look nice, but on the other hand, maybe that makes it look even nicer, right? If it's just like that. But let's get rid of that. We don't know what color our ghost is going to be in advance. And so he needs a direction, and he needs a speed. All right, and why not a name variable, right? Because their names are, I don't remember what they are. Shouldn't have closed the program. Ghost names Pac-Man. They're like Inky. Here we go. Blinky, Pinky, Inky, and Clyde. Yeah, alrighty. So we could create those as enums as well if we wanted to, but why limit ourselves just to a certain number of ghosts? We may want to add more names in the future or something select. Anyways, so now we want to create our ghosts, right? Ghost G1, G2, G3, G4. And then we're going to set his information, right? G1 dot X position is equal to whatever the starting position is. Let's pretend it's 0. G1 dot Y position is equal to 0. G1 dot color is equal to, this is the red go. Okay, well, I already see I've got a problem here. And why am I having these problems? This would have worked great if it was a structure. If I replace that with struct, then those errors go away, and now we're cooking. But we want to make this a class. Conceptually, we want to work with classes, and in a class, all the data is considered private. So what we need to do is to provide getters and setters. What are getters and setters? Well, we need a way of setting the X position and the Y position, and we need a way of setting the speed and of getting those values. So for each variable here, I might want to do a getter and a setter. So for example, void set x position. Well, it needs to take an integer, doesn't it? And we're going to say that this arrow x position equals x, right? That's all it needs to do. So down here, when we want to set the x position of the ghost, we do g1 dot set x pos, and we set them equal to 0. Oh, and this is private as well. I want these functions, these methods, to be public, so I need to add the public keyword here in order to make them accessible down here. And now that error goes away. Okay. And I can do the same thing for y position. You know what I'm going to do, though, is I'm going to condense this syntax so that it's all on one line, right? Because the spacing doesn't matter. It matters to us for readability's sake, but the computer, the compiler, will treat it the same. So now I can take that and copy it and paste it and change all the x to y's, right? And he didn't like some. Oh, and then it went away. All right. And so we could set the ghost's x position and the ghost's y position if we so chose. What about the rest of them? Well, we also want to be able to set his name and his starting speed and his direction and his color. Okay, well, that's turning out to be a lot of different things. So here's what we could do is we could write some supersetter, right, that would set all of those different parameters. But wouldn't it be nice if we could create our ghost like this instead? If we could say, let's just comment this out. I want to be able to do this. Ghost, and for the syntax to work, I'm going to have to declare it as a pointer instead. So the pointer to ghost1 is equal to a new ghost, but I want to be able to do things like this. Well, this ghost is blinky, and so he is red. Color colon, oops, sorry. Yeah, that enum is declared with a uppercase C, so I need to do the same thing down here. Color colon red, comma, and his x position is 0, and his y position is 0, and his direction is up. So direction, oh, come on, direction colon up. And his speed, well, I don't know, maybe we should have defined an enum for speed called slow, medium, and fast, right? We could do that. Enum speed, slow, medium, fast, like that. All right. And like I said, these things where you prefix them with the enum name, you don't have to do. So if you think that makes it look better. And he's going to start off going slow. All right. To use this syntax, I have to provide what's known as a constructor. What is a constructor? A constructor is what is called by the new method to set the values of the member variables. So let's make a little note here. A constructor is a method with the same name as the class and, unlike any other method, and no return type. It can have parameters that set the values of instance variables. It is called by the new keyword when the object is being constructed. All right, so let's add a constructor. I'm going to take this constructor and bring it along with me by copying and pasting just to remind myself of the order, right? Because I have a whole bunch of variables here. All right, so the constructor needs to be public or else we couldn't create it. And it has the same name as the class itself, so ghost, right? And then we need these parameters. We need the name, so that's a string. We need the color. We need the X position and the Y position. Those are ints. Int X, int Y. We need a direction. Direction D. And we need a speed. Speed S, right? And then we're just going to set all of our variables up here, right? Xpos, or this arrow xpos equals X. This arrow, and when I say arrow, I mean the dash greater than. Ypos equals Y. This name equals name. This color equals C. This speed equals S. And this, I've already done name. Have I done them all? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. I should have just done them in order. Yeah. Name followed by color, followed by the positions. Oh, and direction. And then speed. So this dir is equal to D. Okay. So now I can create my ghost like that. And I can make 4 more, or 3 more. Well, I can make as many different ghosts as I want, but we better come up with new colors. All right. Pinky is the pink one, and inky is the blue one. So this is going to be Pinky. Who's pink? And we need 2 more. Inky is the blue one. And Clyde is the orange one. All right, there we go. Right. Whoops, orange was supposed to be in caps. So instead of having all the huge sets of variables, right, and setting a whole bunch of values one at a time with a whole bunch of assignment statements, we're clustering the data together so that ghost 1 contains all of his own information, and ghost 2 contains all of his own information, and ghost 3 contains all his own information, and ghost 4 contains all his own information. So what if we wanted to display some information about each ghost, right? What if I wanted to be able to do PG1 arrow print, right? We're going to print some information about that ghost. And we want to do the same thing for PG2, PG3, and PG4. We've got several ghosts going on now. Well, this is a new method that we're going to have to add. So we need to go add another function up here. So along with the constructor, we need a print. So it doesn't need to return anything, does it? So void print doesn't take any arguments, did it? If we scroll back down here, right? So what was it going to do? It's just going to print out the data, right? So cout ghost name equals, end quote, less than. Now, a secret is that, I mean, it's not a secret, is that you do not have to prefix all your variable names with this keyword. It's nice because you get a pop-up list of all the members of the class, but it's not obligatory. The only time it's absolutely obligatory is when you have a parameter of the same name. Since I have something called name here, I have to distinguish that variable from this one by prefixing this one with the name of the class. Excuse me, with the this reference. So to save time, this time, I almost always do it, but this time I'm not going to. I'm going to just and let's see. I guess we could put a comma there, kind of pre-printing it, right? And so his color, I guess we could leave this off too if, nah. So his color equals, in quote, less than, color less than a comma, followed by a space. Yeah, I've changed my mind on that. I'm gonna just put the comma and the space right there, right? And see out, comma, and his direction equals less than, dir, see out less than, and his speed is equal to less than speed, and his x and his y position, see out, comma, x, y equals, followed by x position, followed by a space, followed by a y position, and then finally, after all that, an ENDL, right? All right, I wonder if we have any syntax errors. I see something going on down here. Maybe it'll go away when I build it. Nope, no such luck. All right, let's go see what the build error is. Looks like some garbage syntax left over from when I was deleting things. Yeah, I think that's the case. Alrighty. So we run it, and here it goes. All right, and we have 4 ghosts. Blinky, Pinky, Inky, and Clyde. Color 0, 2, 1, 3. Well, I don't want numbers there. The directions, he was going up, and so that's apparently direction 0. Well, we're going to have to go and figure out what these 0s and 2s and 1s and 3s mean. And his speed is 0. And okay, so why are we getting numbers rather than names? Because when you do an enum, it's really just an integer. And what we're saying is that whenever I declare a variable of color, behind the scenes it's an integer, and the color red is a 0, and blue is a 1, and pink is a 2, and orange is a 3. And direction is an integer that can be set to one of any 4 values, where up is 0, right is a 1, and down is a 2, and left is a 3. So we're going to need some kind of function to convert these into a readable, human readable string. I mean, I guess we don't have to, but I'd like to know the names rather than just the numbers of the colors. So we do have to declare an array of strings. So I'm going to call them colors, like with a S for string, I don't know, is equal to, and I'm just going to copy this and paste it, but I'm going to put quotes around them, right? Got to put quotes around each one because they're strings. It's an array of strings. And they are positionally linked by their subscript, right? That position is 0, and so the element at position 0 is red. That position is 1. I know you can't read it, but there says enum color blue equals 1. Well, element 1 is that. And so if pink equals 2, then element 2 of the string array is that. We could do the same for the colors, right? Excuse me, for the directions. String directions make it array is equal to, and we're going to copy these. There we go. And lastly, for speed, string speeds is equal to slow, medium, and fast, with quotes around each one. It'd be nice if there was a faster way to do this. And I think the C# language has that, but all right. So when we want to print out, ooh, why is everything in error now? Build it, maybe the errors go away. Yep, they sure did. Alrighty. So when we want to print out his colors, we need to print out colors subscript color. When we want to print out his direction, we need to print out directions subscript dir. And when we want to print out his speed, we need to print out speeds subscript speed. Now we'll have some better results, right? Red, pink, orange, blue. Tell you what, let's make some of them go down and left and right and have some of the other speeds, you know, so it'll be slow and medium and fast, stuff like that. We're about at an end of this particular example, but it'd be more fun if he was going down when he was created and he was going left and he was going right. And he was medium and he was fast and he was also slow. All right, so medium. Okay, so there we go. We've created our 4 ghost objects. Now, since we're not actually creating a video game, that's as far as I'm taking that example. But we see that the class is a collection of data. Well, it's a blueprint. Here, let's write this out down here where I had written the thing about constructors. A class is a blueprint for a collection of data and the functions, which are known as methods, that use that data. And so the data are the variables, right? The member variables. Go back and look at here. Not there. Let's look at the PowerPoint. Where's the PowerPoint? So a class allows a bundling of variables. See, this is an outright lie. I don't know why this textbook's lying to you. There's no difference between a class and a struct except for whether they are private or public. But conceptually, we consider a struct something that's got data only, and a class can also have functions. Now, does that match reality where they made structs allow functions as well? Nah, but let's go with that. So an object is an instance of the class in the same way that a variable can be an instance of a struct. Right? So when we do this new command down here, this new function to create a new ghost, that creates a ghost object. And we store its address in this pointer. We create another ghost object and we store its address in that pointer. So these aren't really the objects. They're variables that point to the objects. Kind of a subtle distinction, right? But you have a blueprint. Can you go and can you move into your blueprint? No, you can't, right? Blueprint is not a house. So the blueprint is the class, right? The house you make from the blueprint is the object. But just because you have a house and a blueprint, you don't know where it is. You still can't move into it, right? That's what the new keyword does. If we did this, it would create the object just fine, right? But there's no name for it, right? So we need an address as well. So we need a variable to hold it. And so the variable holds the address of the object. So we have our house. Okay, I guess I swapped these for the metaphors and then the what they really are. So you want to make a house. The blueprint is the class. The house is the object that's made from the blueprint. And the address is the variable that points to it. Now we can usually call these references. PG1 refers to that object, or PG1 points to that object, right? Let's go back over here. So the class is a blueprint, and the objects are houses built from the blueprint. You can make a whole bunch of different houses from the same blueprint, just like we made multiple ghosts from the same class. And so the attributes are the members of a class. And the methods or behaviors are the member functions of a class. So by this textbook's definition, these are the attributes, right? They're also known as member variables. So these are the attributes of it. And in fact, some people call them properties, and some people call them fields. Different textbooks call them different things. Member variables is kind of a more generic term. Attributes is good enough as well, right? These are the attributes of the class. They're the data of the class. They're the class variables. One last thing you can do is you can call them instance variables. Why are they called instance variables? Because instance is another term for object. An instance is an object. You build your house. Well, that house is an instance of the blueprint class. Kind of a weird term. But each ghost can have different names and different colors and different directions and different speeds, and so they differ on an instance by instance basis. One ghost has one set of values, another ghost, that instance has a different set of values. So that's another term for them. Sorry for the millions of terms for them, but we're smart, we can handle it. And then these are the methods. Right now we only have four methods, right? We have the constructor, right? This is the constructor. And we have a print method. And we have an setters for that. And when you have setters, you usually want to provide getters as well. Technically, setters are called mutators. That's their technical term. Got to speak Latin sometimes, don't we? But along with our setters, we want getters. So let's write one called get x position. Now it doesn't need an argument, right? Because we're getting something. We're not setting it. And what does it do? It just returns this arrow xpos. And then get ypos looks almost the same. So I'm just going to copy and paste it. But actually, I'm going to do this kind of condensed format. Make it easier to see. So this is known as a getter. Its Latin name is accessor. And we want one for y as well. And so it's going to return to y position. All right. Now, if you have methods that don't change the data, they use the data, but they don't change it, we're supposed to mark it as being const compatible. C-O-N-S-T compatible. And I'll show you why in a minute. Now, does the print function change any of the data? No, it does not. So we can also mark it as being compatible with const variables. What about the setters? No, the setters do change the data, so we're not going to mark them as const. Same for the constructor. The constructor changes the data, so we're not going to mark it as const. So what's the big deal about that? What if we made a ghost, but it was a constant, right? We weren't ever going to change it. So we use the word const, right? Here's our new weird ghost. He can't be changed. Don't know what use that would be, but let's just go with the example. All right, so this is our constant ghost. He's declared as a const. His name is P5. His name is I don't know. All right, and so we feel like printing him out. Great, PG5 arrow print. And then now we're going to change his X and his Y position. He's constant. We're not supposed to be able to change it. Just like if I declare a variable called pi, and I set it equal to 3.14159, since I've marked it as a const, or if I mark it as a const, then my program can't change it later, right? I can't set it equal to 4. Good thing, because that would be more inaccurate. We want the same kind of thing to happen when we try to change a constant object. So, well, try to change an object by its constant pointer is a better way to say that. So if we say PG5 set X, well look, set X isn't even one of the available choices. Why? Because set X and set Y are not options that are compatible with consts, right? You can't set the X and the Y position of the ghost except when you create it, because it's marked as const. And so using that lets you create variables that are constant, or let you create parameter variables that are marked as constant, and then you know that that object is not going to be able to change the data. All right, let's keep going. One more thing we need to do is that whenever you create objects with the new keyword, we need to delete them at the end of our program before we return. Looks like we're missing our return statement, right? So we need to delete PG1 and PG2 and PG3 and PG4 and PG5. Excuse me, I need to use the whole word, don't I? It's not a function call. There we go. Sorry, wrong language. You gonna go away? Yeah. Showing it as an error, but it's not an error. All right. Silly thing. Now we're going to delete PG2, delete PG3, delete PG4, and delete PG5. What does that do? It goes and frees the memory. It releases the memory owned by that object, because each time you use the new command, it goes and grabs a couple more, bytes of RAM to hold that object. How many bytes of RAM? Well, I don't know how big our ghost object is. Let's find out. Let's see out the size of our ghost. And so, since I'm referring, I don't want to print out the size of a pointer. I want to print out the size of the ghost itself. Then I need to prefix that with an asterisk, because otherwise I'm just printing out the size of a pointer, and that's no use. Alrighty. Right, there we go. And so each ghost is 48 bytes. Is that a lot? No, but some objects can be huge, right? You could have objects that are kilobytes in size or more, like a photograph. Images can be 4 megabytes, 8 megabytes, whatever. And suppose you had a different object holding different photographs, and you kept allocating more RAM to hold each photograph, and your program never released it. Then conceivably your program could run out of memory. So for example, what if I had a loop here for int I is equal to 0, I is less than 1,000,000, I plus plus. And I'm going to create a new ghost, right? Ghost star pg equals new ghost, and I need I'm just going to grab one of these for, sample information. There we go. And then I do something with it, whatever is important that I needed to do with that. Right? This is going to create a million different ghosts and never release them. So we're going to have used up 46 million bytes. Now, I don't really want to print them all because that would take forever. Print a million things. So how about we only print every 10,000th ghost created? So if I mod 10,000 equals 0, did I make that a 10,000 or 100,000? How many zeros does that get? 1, 2, 3, 4, 5. Yeah, let's do 6. Every 100,000th ghost we make. Oh, let's do every 10,000th. What if it doesn't work? All right, and so here we go. Right, it's using up more and more RAM. But we didn't run out of memory. But it's conceivable that we could have. And if we change this to a gigabyte, and we print out only every millionth of them. Anyways, let's give it another go. I mean, it seems like it's moving slow, but it's actually creating a million ghosts between these things, or at least 100,000. How many zeros did I put on here? 6? 1, 2, 3, 4, 5, 6. Yeah. Million different ones. So I'm surprised we haven't run out of memory, honestly. I don't even know how that's working, how it's managing to grab enough memory. I mean, I know I got a lot of RAM, 32 gigs on this machine, but I'm surprised that it's letting it do that. Anyways, if you don't want that to be a problem, and really you don't, then anytime you use a new keyword, eventually you're going to want to delete it. Now that frees it up. That makes it so that it's not using any more RAM than it's supposed to. Now we don't have any way of measuring that, but if we popped open a system profiler or something and we had watched this program run before, it would have been, the memory would have been continually increasing, and now it's not. Hey, I wonder. Using my activity monitor, if I run this program, can I see its memory increase? Well, I don't even remember what it's called. Lecture. It's not showing up here. I could probably find it in the Windows system monitor. Task manager. Get that up and running. Now let's run the program again. Go back to the task manager. More details. Here's how much each process is using. See, it's continually grabbing more and more RAM. That's called a memory leak. When a program allocates RAM for an array or for an object or for a structure and doesn't delete it, that's a memory leak. Okay, so enough about that. But there is something called a destructor as well as a constructor. Now let's say that for some reason a ghost needed an array. I don't know what. So we're going to make an array variable. Actually, we're going to use it as a pointer. Oh, I had trouble with this last night. The syntax for creating an array and not filling it in. Is it going to let me do that and then allocate it inside the constructor? I hope so. Let's give it a shot. This array equals new int, and we want 1,000,000 bytes at a time. One, two, three, four, five, six. Expression must be a modifiable L value. Well, if I make it a pointer, is that going to fix that? All right, okay. So we've allocated a pointer to 1,000,000 bytes. And even if we're deleting them, did I close the, yeah, we ran out of memory. Unhandled exception, bad allocation of memory. Well, that's because I forgot to delete my objects, didn't I? So let's uncomment this out. Run it. Oh, stop the debugger. Run it. All right, it still blew up. Hey, why did it blow up? I was deleting my objects. Yeah, but the object itself allocated memory, right? The object itself grabbed a megabyte. So we need to write a destructor that will release that memory, right? So a destructor got a similar syntax. It got the name ghost, but its name has got a little tilde in front of it, which is the key right to the left of the one key. You know, it's the shift of the back apostrophe. And then you do that, and inside the destructor, you put any cleanup that needs to be done. Now, in this particular case, the only thing that needs to be cleaned up is that array. So delete this array, right? Now, if you declare an array using a normal syntax, like, you know, there, now I have an array of 10 ints called Fred. You don't need to add that to the destructor. But if you have the new keyword, and anytime you have the new keyword, you need to worry about memory leaks. So anytime you have the new keyword, there needs to be a way for that to be deleted. The way that gets deleted is with a delete call. And to make sure that your object cleans up all of its own memory, you add a constructor to your object, so that when you call delete on it, it comes up and runs that destructor to free that megabyte of RAM that I allocated. Now it should work. Let's stop the debugger. Let's run it. All right, so there we go, right? Shouldn't crash. If I find the activity monitor again, why didn't it stay open? I guess I accidentally closed it. Not using much memory. Well, it seems to be using a lot, but certainly not as much as it was. And when you run these applications, you've probably noticed that over here, you have profilers, right? Process memory. This thing's using up 26 megabytes of RAM. And I wonder why it's using up that much, why it didn't free the RAM. And yeah, each ghost that we created up before that, I know that we created 5 ghosts up here. You know, when we created Inky, Pinky, Blinky, and Clyde, and then this I don't know ghost. So there should have been 5, but I don't know why we have that much left. Why we have 26 left. Are we done with the loop yet? No, it's taking a long time to allocate a megabyte of RAM at a time. These things were being created much more quickly, weren't they? But now that we're allocating them and then freeing them, that seems to have slowed it down a little bit. Ah, well. So Mozilla Firefox, you know, the browser, used to be a notorious memory leaker. people leave their browsers, up and running for days, and you keep using your program, and then you'd check, your resource manager, and it would show that Mozilla was using 4 gigabytes of RAM, or something insane like that. And it's been cleaned up a lot. It absolutely has no problems like that anymore. It's nice and efficient. But in olden days, it was known as a memory leaker. So it would allocate RAM and not release it, and that was memory that wasn't available to the other programs on your system at that time. So it wasn't a good thing. It's a good thing that they fixed those. All right, so we're going to do one more short example of a class, something a little bit more concrete than a Pac-Man. We're going to do a circle class. And I'm wondering if I've already done this. I mean, I know I did it last night in my other lecture. So what does a circle have? All a circle has is a radius, right? Yeah, but let's make it a double. That's all it's got. And we want some methods for it. What methods do we want? Get area and get circumference. And so those are calculations. They need to return double, right? So get area. And this is const compatible because it doesn't change any data in it, right? We're just getting the area. We're not changing anything. And so I'm not going to go in and add CMath or anything like that. So I'm just going to, well, I think I will add CMath just so that I can get POW. But I know that there's something I have to add so that I could get a hold of the pi word. I'm not going to do that. I'm just going to use 3.14159, which is stupid. So anyways, what is the area? It's pi r squared. So double area is equal to 3.14159 times POW, radius to the power of 2, right? And then we need to return that value. All right, and let's get the circumference, right? Get circumference. It also doesn't change the data, so we're going to mark it as being const compatible. And the circumference of it is equal to 2 pi r, right? So 2 times 3.14159 times radius. And we're going to want to provide getters and setters. That's known as encapsulation. Professor's recommendations for creating classes. 1, name begins with a capital letter. Now that's not just my recommendation. Everybody does that in every programming language, and there's about every programmer out there does that nowadays. So the name begins with an uppercase letter. You make your data private, which by default it is, until you put the public keyword. You make your members function public, which is why I have the public keyword. Now you can have private functions if you want. You just put another private keyword and go on from there. And those would be functions that could only be called from within the class, not from the client code down in main. All right. And so for provide getters and setters, which are actually called accessors and mutators. And 5, add constructors, because there's more than one type of constructor, if it makes the class easy to use. And 6, add a destructor if the class allocates memory with the new keyword. All right, so we've got our data private, we've got our members public, we don't have getters and setters. There's only one piece of data. Whoops, too many closed comments. So we need get radius and set radius. Now get radius needs to return a double because that's what type the radius is, and it is const compatible, right? So return this hyphen arrow radius. Sorry, I guess that goes to the... Oh, I forgot. It's a function definition, isn't it? It needs those things. There we go. Right? But the setter is not const compatible because it's changing the data. But when you set data, you don't need a return value. And this dot radius is equal to, well, but we need to pass the radius in, don't we? Right, there we go. So that business about adding constructors if it makes it easier to use. Well, if I do this, circle PC1 equals new circle, and then I can do PC1 arrow greater than set radius to 10. Well, I seem to have some other issue going on here. Oh, I forgot to make it a pointer. There we go. Right? Okay. Maybe it would be nice if we let ourselves do this, right? Circle star PC2 is equal to new circle with a radius of 10, right? Then we wouldn't have to call the setter. We could if we wanted to. However, we can't do that because there's no overload for it. Excuse me, there's no constructor for it. So let's go and add a constructor. A constructor is a method that has the same name as the class, and it can accept parameters. It has parameter variables, or it can have parameter variables to set the data. So, circle, double radius, and then we just set the radius, right? This arrow radius equals to the radius parameter that's passed in there. See, that hooks up to that. That's why we have this keyword referenced in front of it. And that hooks up to that. Okay, cool. We're going to be able to run. Everything's going to work great. Nope, not yet. That broke this. You get what's known as a default constructor. And a default constructor is something that does absolutely nothing by default, but C++ provides it for you so that your code will compile and you don't have to go and add a constructor for every class you make, only if you want to. But once you add a custom constructor, technically a parameterized constructor, why called that? Because it accepts a parameter, then the default constructor is no longer provided by C++. And if we want it, we're going to have to go add it ourselves. So it's a default constructor. Well, we're going to write a constructor that doesn't have any parameter variables, and maybe it just sets the radius to 1 or 0, you know, something. Circle like that. And honestly, it doesn't have to do anything, but it'd be nice if we set it to some default value, right? Like that. Okay. So down here, and we can get that information about our circle. Let's write a function called print for this. So void print underscore circle, and it accepts a circle. But since these are pointers, why don't we make this one accept a pointer as well? So I'm just going to call it PC, a pointer to a circle. And since this function is not supposed to change any of the data, it's just printing it, I'm going to say that data is a const. Nothing's going to change the data. All right. Then we can see out circle has area of see out less than PC greater than arrow get area parentheses in parentheses semicolon see out. I guess we should have said a radius, right? Circle has a radius of see out less than PC get radius, semicolon, cout, comma, an area of, semicolon, and then comma, and a circumference of, semicolon, cout less than PC, get circumf. Oh, and then an ENDL to wrap things up. And yeah, we could have condensed this, to take up less space. Like maybe move that there. Yeah, great. I'm breaking it while I'm doing that. Maybe move this here. Maybe move this here. Yeah, like that. Does that look prettier? I don't know. So now we can print our circles, right? We've created 2 circles. Let's make one with a radius of 5 and the next with a radius of 10. And we might even make one with a radius of 0, right? So star pointer to circle 3 is equal to new circle. We're not specifying a radius, so it's going to get that default value of 0 that we see up here in this default constructor. So I'm going to come back down. Here's my circles. Let's print out all 3 of them. Print PC1. Oh, let me guess. It was called print circle. Print underscore PC1. Print PC2 and print PC3. And then let's just do system pause here so we don't have to see the rest of the output. Ooh, build errors. How about that? Non-standard syntax. Oh, I forgot the parentheses. There we go. Still build errors. Must return a value. Oh, and that's true, right? Get circumference. We calculated the circumference, but we never returned it. And there we go, right? It's printing out the stuff about our circle of radius 5, 10, and 0. And there we go. So this is a smaller, more concrete example, right? Rather than the Pac-Man one, which had a whole bunch of information and we never actually did anything with it. This time we have a little bit of information and we're actually doing stuff with it. And so a criticism of object-oriented programming, for example, my wife is a professional programmer and she's taught in the ways of procedural programming, which is everything that we've been doing, rather than object-oriented programming. And then she started taking my classes and learning object-oriented programming so that she could start doing C# at work and stuff like that. And it drove her crazy at first that we would do all of this to represent a circle when honestly we could have just done this, right? All we had to do was to go, okay, radius is equal to 10, the area is equal to 3.14159 times POW radius, comma 2, right? And then the circumference is equal to 2 times that, 3.14159 times the radius. And then we could print that stuff out, right? Boom, right? And I would, of course, flesh that out with the real stuff. I've just written something that would calculate the radius in the area in, in 30 seconds. And I went to all this trouble here. Well, it's like if you went out and you built a fence around nothing. Why would you build a fence around nothing, right? Yeah, you spend all this money to build a great big fence and you put it around nothing. Well, this is just a very, very small example. Usually your classes are not going to only have one piece of data, right? And so this looks like a lot to add to handle just one piece of data. But it's a concept. It's a concept that we're learning because what could have just been one piece of data could be 1,000 pieces of data, right? Your photographs, when they're loaded into memory, they have what are known as header tags from the photo, and those header tags consist of pointers to what type of camera took it and the geographic location of where the picture was taken. Now of course I'm talking about digital photography, right? And the number of colors that the photograph has in it and what encoding schemes it supports. And so a photograph represented as an object is actually an extremely sophisticated, complicated object. And so the class to hold a photo would be a long class with a lot of different intricate members. And just like we saw with Pac-Man and with the Pac-Man ghost, we were dealing with a lot more information. And so to get the ability to create ghosts this easily and to use them, and pass them around and stuff like that, the expense and time of putting it in a class is minuscule compared to the savings we get in the conceptual simplicity of being able to group all that data together. Kind of hope that makes sense. So yeah, it looks like a lot just to do a circle calculation, but it's the concept that's important, because the concept, you build a fence around nothing, then it took a lot of money and it seemed like wasted effort. But if you build a fence around something that's incredibly valuable and important, then you don't mind spending that at all. All right, so that's enough of this lecture, I think. And so I will see you next time.